So shall I start?
Yeah, you can.
Okay.
Thank you.
So if you remember, we saw during Monday, I showed you that we can use NCI actually for covalent, not only for non-covalent, but also for covalent interactions. If we want to look at the reaction, and you see here, we going back from our H2 example, remember that we have, for example, here we have, at the end, we are going to have this H2 molecule formed starting from this complex. So in this case, we will end up with a covalent interaction here. Hold on. With a covalent interaction over here. What happens? This covalent interaction has a much greater density. So at the beginning, if we're just looking at non-covalent interactions, in this complex, we will only see the non-covalent interactions, which are from the metal with the hydrogen and with our N2. But if we actually want to look at covalent interactions, we will have to increase the square or the rectangle where we're analyzing the data, right? Because these are the covalent interactions. They usually appear at around 0.15, 0.2. So we want to change this rectangle to include these peaks, which appear right before 0.15 in absolute value. So that's what we're doing here. We're changing the value of the cut plot. We're saying we want up to from minus 0.15 to 0.15 so that we include these peaks, and up to S equals 0.5. That's exactly what we're doing with this keyword. And in this way, we will also see the covalent bond formation and breaking here. So we can visualize how the HH interaction is forming and the NH is breaking. So with this, I'll invite you to create files for H2 at 0.7 angstroms, which is the distance one would be expecting for the molecule. Go ahead.
Okay.
So as you can imagine, the best way to do it is actually to plot these data files and see where your peaks are, or you do it in, or you try something close to this and then you visualize it. Okay. Oh, sorry, I forgot I was not sharing anymore. So if you plotted that file, it's pretty easy to actually do it. So go ahead.
I guess I did it. It's supposed to be blue with a little head, right?
Julia, I think you got muted and I couldn't hear you.
So please, I was telling that so please show us.
Oh, of course. Just a second. I think I don't have the permissions to present.
Why not?
No?
You should. Why not?
Yeah.
Try to click on this button here below with the window and share the entire screen, or
yeah, but neither is working.
Wow.
I'll try to leave the room and come back and see if something changed.
Oh, maybe are you using your smartphone for this meet?
No, but I have a 2-screen setup. Maybe
okay.
That's the problem.
No, because for on smartphone, it's impossible. Okay. Anybody got?
So if someone copied,
Yes.
just show us.
I can try to share if that's okay.
Yes, absolutely.
Please try.
So this is the figure I got for the 0.7. Can you see?
Very
my screen?
nice.
Yeah.
Yes. So what input did you use?
What input picture?
No, the input. What did you write?
Oh yeah, so that's just the standard one that was here in the file. I didn't change the keyword. Maybe I should do that now.
Ah, because you were supposed to do it on your own. I didn't tell you to go into exercise 1 yet.
Okay, sorry. I just thought that.
So you were supposed to
what you meant.
create the input on your own.
Okay.
But that's the result anyway. So the others managed to do it too. So you see how to use the keyword catplot in case you want to analyze reactivity?
Yes.
Okay,
Everything's fine.
nice. So let me show you how you would do if these were wave function files. So remember, up to now we have been working with, so let me show you actually. So first of all, let me show you how because the one you have used is wave function actually, which we have not seen yet how to read. If you had done it on your own, you should have something like this. So that's the input with the XYZ file, and you would have had to create the XYZ file, which looks like this. So 2 atoms, one at 0, 0, 0, and the other one at 0.7. Okay. Now let's imagine that we want to use wave function files. Then our input will look like this. So instead of XYZ, here we will have a wave function file. And the wave function file looks like this. So it contains all the information. It contains the atoms, where they are, but in atomic units, the centers. So all this is the exponents for the constructing the molecular orbitals here from these atomic orbitals. Okay. And for obtaining it, since we said that some of you didn't know how to do it, let me show you one example. If you're using Gaussian, for example, and you want to do methane water, which is something we'll be doing later on, what you need to add is this output equal WFN in the instructions. Here you leave one line, one white line, empty line, and then you add the name of the wave function you want. So is this clear to everyone who didn't know how to calculate it?
Yeah, absolutely. Yes, good.
Okay.
So
Luciano, do they have access to Gaussian on the cluster?
Yeah, I have here some Gaussian users, but in the clusters, to use the Gaussian there, it's complicated during the course here because we need to use the queue,
okay.
it's learned, and the queue is too long. But
no
yeah, but I could see that you carried.
Okay, so what I can do, So actually, in the exercises I showed you, you should have, I think I included, there you go. So I included everything we discussed also yesterday. So I have included now the visualization with VMD instructions so that you have them written. And also I have added how to do the calculation of the wave function file. So here you have one example here with the output equal WFN, okay? So you have all the instructions before and after NCI plot. In the PDF, I just gave you the link for. So this is the updated PDF.
Nice, good. After that, Julia, after you, I can show to them here from my screen the input file for Orca package.
Absolutely, go ahead. Yes, please. File. Go ahead. And if you send it to me, I can update the PDF and send them the updated PDF with all the information so that everything is together.
Julia, can I ask a question meanwhile?
Absolutely.
So, sorry if I didn't understand correctly, but then there is two ways to run the this calculation. I can use the coordinates only, or I can use the wave function.
Absolutely.
Yeah. So, yes. What is exactly the difference in the results? What the software is going to do without the wave function when I only give the coordinates exactly?
Okay. So it's two levels of approximation. If you only use the coordinates, let me show you back the slides. Hold on. So if you use the coordinates, you're using a promolecular calculation, which is the one here. The one I told you, you're using a sum of atomic densities. Mm-hmm. And a sum of atomic densities, it's not a relaxed density. It's like SCF equals 0.
Okay.
So there is no quantum mechanics in this calculation. It's a very crude approach. So basically, let me add, so basically, if you can do the calculation, the quantum calculation, you use WFN. You should only use promolecular when it's a huge system, like a biomolecule.
Okay.
Or if you want to do a super fast test, you don't want to do the wave function, you would just want to do a test and then you run the wave function.
Okay.
But it's fast, but it's much less precise.
I please, Michael.
Oh, cheers. No, I was just going to ask if you're doing a calculation, for instance, can you, if you are running a solid state calculation, VAS, for instance.
Yes.
Can you generate some the wave function from that, or
you can generate the grids? Okay, so while Luciano generates, shows you for Orca, I will also generate your something similar to what I've sent you with the exercises with the instructions, but for critic, which is the solid state, and I'll send it to you.
I mean, it's just curiosity. Don't worry about it if it's too much trouble.
No, I have it from because I'm also doing these classes for solid state people. Yeah, so I have them.
Yeah, and I don't know if you use VASP, Julia, there.
Yes.
Yeah, but also after Marcelo can help us with the Quantum Espresso package.
Yes.
That would be nice if we have time.
For sure.
Marcelo can also show to the class here. About the comment from Michael, just to share here an idea about the scientific paper. Yes, Julia, maybe, I don't know if you agree, but for publication using the promolecular density, okay, and NCI plot to support these results in a scientific paper in a journal would be nice from MD simulations. Also, for example, characterize the hydrogen boundaries from other tools, from other analyses.
Yes,
this is possible from MD simulations, and if both our results agree well, then we can have a high quality results to be published, you know? Okay.
Yes. Yeah. All these tools, they're nice. They're nicer if we combine them.
Cheers. Thank you very much.
Julia,
Yes.
may I ask a question?
Yes, absolutely. Go ahead.
Is there any restriction about the wave function type? Like, for example, would I
Yes.
use multi-reference wave functions or? No?
I believe in the last version, I should have to check. I think normal, because I'm not so much into. I tend to avoid open shell multi-reference methods. I think you can't unless you project it.
Okay. Okay, thanks.
Julia, can I show
Yes.
my result here?
Absolutely.
I have
Go ahead.
I plot a very crude graphic here using
So for the previous question, I was just thinking, you can actually use multi-reference. You cannot use, we don't have CAS, for example.
Okay, okay,
So-
thanks.
yeah, I just plot that file for 0.7 angstrom, but it's a bit different from the, I don't know if I did well, but I use the same inputs over here,
Yes.
but
Yes. Very good.
the results
It's
looks
yes, they're different because I did not have the promolecular approximation. So these are the results from wave function. So bravo.
I see. Okay, thanks.
But you see, the shape is the same. There is a shift when we go from promolecular to wave function. That's the main difference.
Yes. I noticed that. Sorry. Thanks.
So, Luciana, you show us with Orca?
Okay, just a minute. Can you see the screen? The input file?
Yep.
Can you see?
Yes, I can.
Yeah, good. So for Orca input file, you need to put in this line. This is like for Gaussian. For Gaussian, you have here the hash to start the line. For Orca, we need to put here the exclamation signal, and we need to put this flag AIM. Together with others, leave your theory and other things in the input file. So the output will generate automatically the WFN and also the WFX output
Yes.
files, okay? I'll try to share my input file with everyone after, okay?
Yes, because also then I can add it to the PDF.
Okay, thank you, good.
So, so now you're ready. You've seen everything we needed. Why don't you complete exercise 1, which is what we have been working on? You complete the questions, and start doing exercise 2. And if you have any problems, you let me know, because you should be ready to do exercise 1 and 2 on your own. So we go ahead and just let us know if you have any problems. Everything going fine?
Yes, yes.
Okay.
Yeah, I think so.
Maybe someone can share the results with us.
Yes. Have you finished? We have done in class mainly exercise 1, except for the DAT files. So whenever someone has finished exercise 1, let us know, and we will share it together. Luciano, are you also trying?
Not in that moment.
Okay.
It wasn't possible for me here. Sorry.
No. I was just wondering whether I could use you as a reference.
Okay, good. While here with you, I have my two kids. Yes, Enrique will have the exam today, and I'm teaching him English
Whoa.
for the exam. 9 years old. In my class, Julia, when, for example, we don't have any volunteer to show the results, I pick up someone like
voluntary. First, voluntary. Absolutely,
yes.
me too. But I'm letting them time, because since I see they're actually pretty active, I assume that if they haven't shown us, it's because they haven't finished yet. I'm giving them the doubt.
Yeah,
That
really.
in 5 minutes, I'll ask randomly otherwise.
Yeah, exactly. In a virtual class, I don't know if this happens with you, but sometimes. Could you hear?
Yes.
So I need to go, but sometimes I could see a student that got muted with no words along the class.
Yes.
And when I finish the class, he continues there online. And the class being recorded. I let this being recorded for a couple of minutes, like almost 1 hour, and the student always on in the class. And in the next class, I asked him, "Wow, I could see that you stayed online for long time. Why?"
And what did he say?
He practically got so ashamed about my questions, and never stayed after the time. and be active in the next classes.
Okay, so at least it was useful for something.
Yeah, exactly.
I just did methane water and methane ammonia. I can share if.
Yes, please.
Okay. Yeah, I still don't have the permissions to share. I don't know why this is happening.
So you don't manage?
I'm sorry?
So you're not able to?
Yes,
Luciano, why can't Piaco not share? So what does it say?
Mm,
So you're clicking on the present. So the icon with the square and the arrow.
it says you need to concede permissions to share. Oh, I know what I'm doing. It's my fault.
Okay. So I just sent you the exercises, the sheet with also the solid state stuff, Michael.
Oh, great. Thank you very much.
Just a second. Don't know if you can see, but
Not
this.
yet. It says presentation, but we don't see it yet. Can you choose to show all your window? Because in my case, it doesn't work if I don't choose to show you everything.
Yeah, it's exactly what I'm doing. Try once again. Yeah, I guess you guys can see anything yet, right?
We don't see anything.
It's probably my browser. I don't know. I tried something else.
Well, otherwise, if you have the pictures, you can also send them to the chat.
Yeah, that's a good idea.
I think I got it here. The methane cases are these cases.
I don't see anything.
No, it's me, Marcelo.
Ah,
I think I got here the calculations.
okay, so maybe Marcelo can share and Tiago will comment since he got the results earlier.
Yeah, I guess it will be easier and having
So we will
some
do a
technical
collaborative
problems.
contribution.
So that you can check if it's all right. If not,
Yeah. So Marcelo, go ahead.
yeah, I'm sharing.
Okay.
So this is the methane case, methane dimer. And
Okay. So what do you see? Tiago.
For me, it looks like a delocalization. Sorry, I'm having trouble with this word. Delocalized.
Delocalized interaction.
Yes.
Yes, it is.
Van der Waals interaction, right?
Yes. Very good. Marcelo, do you agree? All the
Yeah,
others?
for
Okay,
sure.
great. Then do you have another one?
Yes. Let me delete this one and load another one. So, for example, methane, ammonia, or methane water. Simple. Yeah. Also, it's a localized interaction because of the distance between the hydrogen and the oxygen atoms.
So what do you say, localized or delocalized?
Delocalized.
Delocalized. What do the others say?
I would say the opposite because it's directional. You have just a small dot. It's not like the case of methane where you have the surface that goes all along the structure.
Exactly. That's why this exercise is here. Because you have two types of very weak interactions, delocalized interactions. We have seen the typical case of van der Waals, like in methane dimer, where we have a huge surface. This is a typical delocalized van der Waals interaction with many atomic contributions. Here, we have it's called an unconventional hydrogen bond because it's with a carbon atom. So it's a directional hydrogen bond, but very weak. So that's why we see something round and green. So it's localized like a hydrogen bond. It's directional, but it's weak because it's a carbon hydrogen bond.
Oh, I
so
see.
It's an unconventional hydrogen bond. So it's very good, guys. Thank you very much. You did a perfect illustration. The teamwork works perfectly.
Julia, if I can add a question to that.
Yes.
When we are comparing different systems,
yes,
can we have some kind of quantitative measurement of the different interactions?
So you can use the integrals that we will see in the third exercise, maybe today, maybe tomorrow, depending on how we're doing.
Okay, that's good. Thank you.
So, Julia, this range here is the density range, right?
Yes.
Okay.
But it's multiplied by 100. And the reason why, it's because VMD does not take very small numbers for the range.
Okay.
So it means that it is going from minus 0.05 to 0.05 in the real density values.
See, yes, I see. And this isosurface, I can choose another value here that...
Yes, you could change it and it would be bigger. But then when you compare with the other one and choosing the same isosurface, the other one would always be bigger and like covering many atoms. And here it will always be circular around the directional interaction. So circular is directional.
Yes. But why this value? This is the default value here, because I have seen that.
Because it's in the VMD script.
No, I see. Okay, and the VMD script takes the value more appropriately from the calculation, right?
No, it
No?
uses a default that is so it's 0.3 for wave function and 0.5 for promolecular. Then you
I
can
see.
change it.
I see. It's from the program.
Yes.
Oh, okay.
So that's why I was telling Luciano that the VMD script is a first, it's order 0. You load it, you have your picture, but then if you want to compare different systems to really get into it, then it's good to play around a bit with it.
Yeah, good.
Okay.
Good tip.
Okay, so how about, so in the exercise, let me now share.
Okay, let me stop presenting here.
Okay. So we have done this part, which was the first part yesterday, but I added, actually to make your life easier, not to go directly into the weird carbon hydrogen bond, I added you the picture of a water dimer and benzene dimer so that you see the typical case of a normal hydrogen bond and a very delocalized interaction. So please do, someone has done these two?
I have the water loaded here.
Okay, perfect. Can you show us?
Yes. Can you see my screen? No.
It's loading. Yes, it's coming.
Okay, so is this for the water?
Perfect. Very nice. So you see it's again very circular shape, bluer.
Yeah.
And so that's a typical image of a hydrogen bond.
Yeah, it's very directional.
Yes, exactly. Someone has done benzene dimer?
And then, Julia, the color is a mix, yes, of blue and green, maybe, yes.
Yes, actually,
Something like that.
Joseph,
Or-
can you show us your VMD?
Yeah, this is benzene.
Okay, perfect. What kind of benzene conformation is that? Someone knows?
Conformation, you mean the...
Yes, it's not the one we saw during the class, which was like this. This one is like this.
It's like T-shape.
Exactly, it's a T-shape. So that's the typical shape of a T-shape that I also showed you for reactivity in the lactates. So T-shapes are localized.
Yeah, and also appears the ring, yes, the ring interaction.
Yes, so you have the ring interaction, and T-shapes are more localized. So they're in between the hydrogen and the pi system, but they're more localized than a pi, as you can see.
Okay.
And the last exercise is about this.
So that's why we have this cone shape. Or,
Yes. Yes.
Oh, I see.
So it's very easy to recognize the T-shapes from MCI.
Okay, good, nice.
Okay.
Yes.
Nice.
Okay.
Can I ask something?
Yes.
It would be possible to perform this analysis on, I don't know, maybe the Actually, this makes sense in both cases, both in solids and in molecules. But my question is that it would be possible to perform this analysis on projections onto orbitals, directly onto specific orbitals.
So that's something that we are developing right now.
Oh, I see.
Yes.
Yeah,
So you will be, so that you're able to tell which orbitals are leading to this NCI picture.
Nice, very nice. Thanks, Professor.
So come on, that's perfect. So we've had someone showing us water dimer and benzene dimer, and the interactions of methane with so two methanes, methane dimer and methane with, was it with water? I don't remember now. Yes, with water. So we've gone through the main how to characterize interactions. Now let's do something where things are mixed. Try the DNA pair, so adenine thymine, and try to plot only intermolecular interactions. Or do both. Plot all of them and then try to plot only intermolecular.
Julia,
So yes, I just realized. So I would like someone who has not presented yet to present the results.
So about the adenine and threonine, we don't have the WFN files.
You should have in the last version. You should have A and T, which are the names for.
But just the XYZ file.
Yeah. So then use
Okay,
them.
okay.
That's okay.
Okay.
So while you advance, since here is the afternoon, I'm going to make myself a coffee. So hopefully someone will have finished by the time I get back, because it should be easy by now. And I really want someone who has not presented yet. Otherwise, I will start asking for volunteers.
Yeah,
For
good.
forced volunteers.
Good.
Okay, I'm back. Who is gonna show the results? I want plenty of volunteers. Come on, guys.
Hello, guys. You decided to have a coffee too?
Yes.
Please, you can't. Just Julia.
Yeah. They can have a coffee, but they have to do the exercises at the same time.
Exactly, exactly. Everything at the same time.
Okay. Enrique de Castro? Oh, Juan Rafael got scared.
I'm here just as technical support.
Sorry.
I forgot Julia. And Enrique is here with me as a technical support. He's the guy that edited our web page and help us with this Santos Dumont server also.
Hold on.
Can I choose someone here? Arley, maybe? Eloisa? What do you think? Arley or
Go
Eloisa?
ahead, Luciano. You choose.
Yeah, Arley or Eloisa can help us, please.
Or they can do together, like before. It shows to be teamwork. It's good.
Yeah, exactly.
Go ahead.
What about Karine, Julielson?
Okay. So, Arlie, that's even better. So, which step are you in? So maybe we can drive you. So, okay. So how about someone who has already presented so they feel comfortable with the code? So Arlie, can you show your screen and the other guys will guide you? Arlie? It can even be in Portuguese then. So how about Arlie, you share your, maybe Luciano, you can also translate. So Arlie can share his screen so that we teach him, and someone else who has already shown results so they know how to do it, or Karim seems to know it too, and you tell him what he needs to do.
Yeah, thank you,
It can be
Julia.
in Brazil, in Portuguese.
Yeah, thank you, Julia. Arley, acho que Arley não, ele é um usuário, assim, ele disse que ele é um usuário mais iniciante, né, que teve alguns problemas de processar todas as informações e que está tendo problema na conexão também. Então, eu vou tentar ajudá-lo aqui em background, ok? Julia, Arley wrote to us here on the chat that basically saying that he's a beginner user and he had some problems to reproduce the exercises, and I can help him in background, okay?
That works. So Karin was proposing to show us otherwise. Karin, how about that? So even if you haven't finished, you can share your screen so that Arlie sees how you do it. Or someone who is lost. It's always a good exercise since some people have different levels. So you can, that goes to all of you. You can speak in Portuguese because this part is all for you. So Karin, if you show your screen and describe how you did it, then maybe we can, the real beginners can catch up. Thank you, Karin.
Okay, I'll try. My connection is not good.
Okay, just show you. We'll try to show your screen. If it doesn't work, then someone else will do, and you will explain how orally, like we did before. Is it working, Karin, or is it too demanding from the bandwidth?
I think she lost the connection.
Yes. Someone else can show us, maybe?
I can try to share mine, but is it the result I want to see now, Julia, or is the step-by-step?
If you can do step by step, because I realized that maybe we have been going too fast for some people. So I showed yesterday how to do, but maybe it's good to make a recall.
Okay, I can try to do that.
Please, thank you. If you can do it in Portuguese, it's even better, or you're not Portuguese.
Yes, I am. I can try.
Okay, so if you can do it in Portuguese, then I think at least we will not have the language barrier.
Should I go for the AT file thing then?
Yeah.
The other thing is I'm running on my laptop, so I'm not using the cluster.
Yes.
I hope that's not
no, at least they'll see how to run the calculation.
And well, I'm using the files you sent. I don't know if I'm doing right, but
yeah, that's okay.
So for instance, the AT, right? So I think the one we had before was the XYZ, right? File. We started that one.
Yes.
Maybe I can create a new folder here, just restart all over again. Yeah, the first thing I did was, well, a primeira coisa que eu fiz foi pegar o arquivo XYZ e criar um arquivo grid com a informação daquele arquivo. Então, eu comecei com esses dois arquivos. Ó, esse não. Esse grid e o XYZ. So this is the two files I need, right?
Yes.
To start with.
That's perfect.
Aí, então, o segundo passo seria acessar essa pasta onde que eu estou rodando. Aqui eu estou rodando dentro do Windows, mas deve ser bem semelhante aí se alguém estiver rodando no Linux. Então, aqui eu tenho que entrar nessa nova pasta que eu criei.
No worries, Karin. We have now a Windows user, which is also very nice, so that everyone gets an example.
Então, aqui dentro da pasta que tem o arquivo grid, o arquivo XYZ, roda o comando nci-plot com o arquivo grid e gera um arquivo out.
Maicon, can you increase the size? Can you make a zoom on your screen so that they can see just with your...
I can try. Not sure how.
So I do it with my pad. I do like this on the mouse, and it increases.
Oh, really? But
Yes.
like, because I see my screen
On my touchpad. Yeah.
but just the mouse, I don't know how to do it. It's not,
Then
if I scroll down or up, doesn't work.
otherwise, this is a virtual machine?
No, it's something called Sigwig, I think, something like that. I can try to increase the size of the text, I guess.
Okay.
Let me see. Oh, here.
Perfect. Ah, much better. So, is everyone being able to follow?
Yeah.
Nice. The people who are very shy, tell me, are you completely lost or?
Julia, here on the chat, Julielson and Arley got lost, and I'm trying to help them
Okay.
about this.
So basically what I did was I got the XYZ file. I made the grid file to run the NCI plot. And I ran NCI plot with this command
Yeah,
here.
yeah, go ahead in Portuguese. I understand pretty much. It's not so, it's close to Spanish. And I think it's better for your, so most people speak Portuguese among the students, right?
Sim, sim, sim.
Okay.
Então, eu tenho o arquivo, as coordenadas XYZ, que ela tinha enviado antes. Aí eu crio um arquivo grid, semelhante ao que a gente estava usando antes para ler esse XYZ, que são esses dois arquivos aqui, né? O XYZ, esse aqui deve estar um pouquinho pequeno, não sei se vocês vão conseguir ver, mas... E o grid, que é simplesmente o número de linhas do arquivo e o nome do arquivo XYZ que você quer que ele leia. É isso, basicamente. Aí roda o comando do NCI plot, que é isso daqui, NCI plot, aí o arquivo grid, e aí o arquivo out que você quer gerar. E só isso que eu fiz, basicamente. E aí, quando você roda esse comando, você obtém os arquivos, o out que eu pedi lá, que é esse daqui, e alguns outros aqui, incluindo o dense e o grade, que são o que o VMD vai ler depois. Aí, se eu quiser abrir isso no VMD depois, eu venho no VMD, eu tenho uns abertos aqui, mas... Aí eu vou em File, New Molecule, aí eu vou procurar por esses arquivos aí. Estão aqui. Aí, no caso aqui, a gente abre o dense primeiro, carrega. Depois o grade, carrega. Aí eu tenho o arquivo aqui, que é esse aqui, dois frames.
Muy bien.
E aí, a partir disso, eu gero a visualização que eu preciso, né? É esse aqui mesmo, né? Isso. Ele está em linha agora, mas eu posso mudar aqui como a Julia falou ontem. Graphics, Representation. Aí, a primeira coisa, esse Draw Style. Aí muda o Drawing Method para o CPK. Aí você tem uma visualização aí de bolas já, né? E aí, para adicionar as interações, você clica no Create Rep. Aí, nessa segunda representação, você muda de novo o Drawing Method para IsoValue, IsoSurface. Muda o Coloring Method para Surface. Volume, para Volume. É isso. E aqui eu já tenho algumas coisas que estão padronizadas, porque eu tinha um outro arquivo aberto, mas você deve ter esse IsoValue 0.3, alguma coisa assim. E esse Draw aqui, essa penúltima linha da caixa, se aparecer em Point, você tem que mudar para Solid Surface.
O Michael?
Oi?
bem observado, né? Geralmente, para quem vai usar o VMD do início, sempre fica points, né? Então, muito boa observação, essa sua. O usuário tem que estar atento a isso, porque ele sempre tem que mudar para Solid Surface, ok? Não é o default de carregamento do VMD.
Isso. Aí, depois disso, tem a mudança do trajectory aqui, que... Julia, should I use -5 and 5 here?
See, since it's promolecular, it's better to use, I usually use 0.5 for the isosurface, but 0.3 it's already enough, as you can see. And -5 to 5.
Okay,
but
I can change this here.
These are options. As you have to make sure you note down the options, and when you publish, you say which options you chose. That's the most important issue.
Okay. So, yeah, então, isovalue 0.5, e aí o trajectory aqui entre -5 e 5, clique em Set. Provavelmente, se é a primeira vez que você está abrindo o arquivo, você tem que ir também em Graphics, Color Scale, e selecionar método BGR, para ficar a ordem da coloração da cor certa. O meu já está aqui porque eu tinha uma outra coisa aberta aqui, e aí ele manteve a configuração.
So, Maicon, you see, if you go back to the isosurface value, you see that now we see things that we're usually not interested in, which are very lots of intramolecular stuff.
Yeah.
So you go back to 0.3. I think the picture was nicer.
Okay. And
Okay,
that's fine.
So that's what I meant. You have to play around, because maybe you're very interested in the intramolecular interactions in the pseudo rings that we were showing before, and then 0.5 is better. But if you're interested in the hydrogen bonds, 0.3, it's clearer. See what I mean?
Yeah.
Okay, perfect. So what do we see here? Since Karin lost connection, Karin, will you tell us what you see?
Before Karin, Julia, please, Michael,
Yes.
please keep your screen. Michael?
Yeah. With the screen of Maicon, since Karin has not good connection, Maicon can show it, and Karin can comment.
I'd like Julia. Can you?
Yes.
Can I add a comment?
Yes, absolutely.
Okay. For a scientific publication with the VMD image, I don't know if Michael knows, but would nice if possible here with this screen on VMD, Michael, show how to delete the box, take off the axis, and generate a picture with the white background, because for like,
yes, you have everything. Okay, all this you have it in the notes I gave you, but it's perfect to show everyone how to do it. Yes, please, Michael.
Do you know Michael?
Yeah, that's what I was going to say. I don't know how to do that.
Okay, that's perfect. I will guide you.
Okay.
Eu tentei fazer com as instruções, Julia, que nós recebemos por e-mail, e eu não consegui mudar o fundo também para branco. Não foi.
No? Okay.
Não.
That's weird.
Okay, let's go.
Okay. Let's go through it, and if it doesn't work, I'll because maybe I forgot to add something. Okay. Background color white. Graphics. Colors. And then you choose display. Background, and you choose white from the list, which is 8, I think. And you press enter. There you go. So,
acho que faltava essa parte, clicar no background.
Okay.
Okay.
So it's very good to do it together, because okay. Now you see that it is kind of foggy. Yeah. I don't know how you say that.
Yeah.
Nublado?
Yeah. Yeah, that
Okay,
will work.
you go to display. Top
Here,
display, and you say depth queuing, you take away the tick. There you go. Nicer. Yes. So this is how to make pictures for papers. Now, you go to display, and this is a personal choice. You see, this one is in perspective. I don't like perspective. Some people like it. So you say orthographic.
Okay. Yeah, I prefer like this, to be honest, as well.
The lines. Yes.
Oh, okay. Era isso.
The lines. You go to graphics. So everyone did follow, or should we repeat something? You should have everything in the notes I gave you anyway, so that you don't forget. You go to display again, and we are going to get rid of the access. Access off. Nice. And last one, graphics, representations, and you have the isosurface. You go at the bottom, you have box plus isosurface, and you choose isosurface. There you go. So you have a picture for a paper. Now you just need to save it.
Nice, Julia. Thank you. That's all good, because especially for beginner, this is not trivial, not easy.
No. That's why I made the page for VMD instructions. Okay, now you go back to the you choose file, render, and it depends which format you want. So if you're on Windows, it's going to propose BMP. That's the default. It's good. You can keep it, and it will save a BMP picture, which is usually not the best. If you're using, but just give it a name. So yes. So 80 and start rendering.
Yeah. Oh, sorry, Julia.
Yes.
I forgot again about the time. Not now. We have more 5 minutes more, and need to finish because we gonna have another session.
So we save the picture and we are done.
Okay, just need to find out where it is now. Oh. Oh, do I need to do this thing? Oh.
That's weird.
Yeah. Okay.
Okay, so it was you have to change the extension to BMP. Okay, and now if you open it, okay, so you have your picture. People using Linux. So can you go to render?
Oh, sorry.
Yes, I'll tell them what they have to, or hold on, I'll do it myself. Because my VMD is also under Windows. Someone who has a VMD in Linux?
Yes, me.
Can you share, Marcelo?
Marcelo?
Okay.
Thank you so much, guys.
While I'm sharing, I have a question. I try to perform the NCI using the intermolecular keyword, but
and it didn't work.
Yes.
Show me the input file.
Okay.
Oh, I had the same problem. You need the a.xyz and the t.xyz, right?
That's what this exercise is for.
Yeah,
Exactly. So I love you guys because
yeah.
you're illustrating exactly what I wanted to illustrate.
Sorry, Thiago, can you repeat?
Yeah, when you use the intermolecular tag, you need two files. You need two XYZ files.
Yeah, I did that. I did that. But the thing is that forgot this line here. I used firstly these 4 lines here. Is that what you're talking about, right?
Yeah.
Okay, but when I generated the NCI plot, it crashed. It didn't work. Actually, it worked, but it overwritten the a dot whatever files, right? So when I put this command here,
that's true. It overwrites. If you use it in the same folder, it will overwrite because it uses the same names.
But even when I was in another folder, so I need to copy everything. But the thing is that it didn't use the AT prefix. It output everything in a dot something, you know.
Yeah.
So I had to put this thing here that I found in the documentation, just for the guys to know. And here is the where is? I'm sorry.
So that's the full, because we have the repulsion inside the rings.
Yes, I'm trying to find the
Anyway, we can continue with the intermolecular tomorrow. Just let's see how to save a picture in Linux.
Okay.
Because you have to go, guys.
Well, sorry.
I share it here on the chat, the link for the session, okay, at 11.
Yes. Thank you, Luciano, because yesterday I used the wrong one. Okay, so you see that now we don't have the interaction inside the rings. So this is especially useful if you're using super big systems like proteins and you want, let's say, the interaction of in between 2 proteins, but there are also plenty of interactions within each protein. Then you get rid of them and your picture is much clearer and you just look at what you want. So you go, in order to save it, you go to File, Render. And now you're in Linux or in
Linux.
That's weird. Okay, so you can you increase a little bit, because at least me, I don't see it very easily.
I'm sorry.
Okay,
how can I do that?
No, that's okay. We will. I think everyone can focus in their screen. So instead of a snapshot, you choose tachyon. There are 2. You choose whatever tachyon.
Which of these? Just
the first one is okay.
Okay.
And at the end, you have a good default targa TGA. You start rendering. Well, you can change the name, VMT scene.
I can change here, right?
Yes, you could have changed it, but that's the name it will have.
Okay.
So you will have a TGA picture, which they look usually better than the BMP. But anyway, you can convert from one to other. You can use converters to go from different formats. It's just that TGA usually is not read by Windows default programs.
Right, here it is.
Okay, so there you go. Okay, guys? So those are the 2 defaults that work well in Windows and Linux. Then you can convert.
Thank you. Good. Thank you. it was perfect.
So
Thank you,
we
Marcelo.
will start from intermolecular tomorrow and last exercise.
Thank you, Julia.
Thank you all. Thank you for being so active, guys.
See you tomorrow, okay, at 9.
Yes.
So, guys, as Julia said, you are the best class we have. Nice.
Thank
very
you
good.
very much.
Bye-bye.
Can I say a thing very fast?
Go ahead.
Yeah.
I have a small script for VMD that
Yes.
you can run directly. You just have to put your files and the script in the same folder, and you can get the picture head. If someone is interested in sending the GitHub link in the
Thank
chat.
you so much. I've been thinking for a long time to do that, but
Yeah, you have to change
but
something.
then I feel so lazy. I actually just edit the VMP file.
Yeah.
I just sent. Thank you, guys.
Thank you, Thiago. Bye-bye, pessoal. Até mais.
Bye.
Até amanhã, 9 horas. Tchau, tchau.
Thank
Bye-bye,
you so
Julia.
much. Bye-bye.